Good morning students, a very good morning to you all. Here I am going to discuss a very good question of this chapter based on relative velocity. What is that is? See the question, do not take tense, the question is so long, right? It is very easy, right? On a two-lane road, okay, on a two-lane road, car A is travelling with a speed of 36 km/h. Two cars B and C approach car A in opposite directions with a speed of 54 km/h each. At a certain instant, when distance AB equals to AC, that is equals to how much? 1 km, B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? See, with our problem we are going to avoid an accident, okay? What the question? See, there is a two-lane road. Assume that this is a two-lane road. Here A is travelling, let us take A, this is A. It is travelling with a speed of 36 km/h happily. Now what happens? Two cars B and C approach car A in which directions? Opposite direction, means this is B and this is C. So B is coming in this direction. What about the velocity of B? Same, 54 km/h. C is coming in this direction. VC is equals to 54 km/h. See, on a two-lane road, one car is already present. Both are coming in opposite directions, right? So they are coming like this. If all these three meet at the same point, then accident will occur or not? Yes. To avoid that accident, they said that the distance when it is AB is equals to AC is equals to how much? 1 km. B decides to overtake A before C does. Okay. So B has to move fast as compared to C, so that it should accelerate or not? Yes. What acceleration it should give so that to avoid the accident? That is the question. What they said, that A is moving on a road with a speed 36 km/h. B and C approaches A in opposite directions. When AB is equals to AC is equals to 1 km, B decides to overtake A before C does, because both are moving same speed. One want to overtake means they have to increase their velocity, that is what acceleration they have to give so that to avoid the accident. First we will convert speeds into meter per second. V is equals to what? 36 into 5 by 18. 18 ones are 18 twos are 2 5s are how much? 10 meter per second. What about velocity of B is equals to velocity of C? How much? 54 into 5 by 18. 18 ones are 18 threes are 15 meter per second. Here have you observed that B and A are moving in same direction, C and A are moving in opposite direction. We can write as velocity of B with respect to A, VBA is equals to what? Both are moving in same direction, so VB minus VA. VB is 15, VA is 10, so how much you get? 5 meter per second. So velocity of B with respect to A is how much? 5 meter per second. Similarly, velocity of C with respect to A, VCA is equals to VC plus VA. How much? 15 plus 10, that is equals to how much? 25 meter per second. Now before these two meet, this has to overtake now. Let us know that how much time will take between to come reach. So time taken, to cover AC, T is equals to velocity, distance is AC by velocity of AC. Distance how much ma? 1000 meters by 25. So to reach these two at the same point, how much time it will take? 40 seconds. Now, in that 40 seconds, it should get acceleration, right? That is the thing, right? So, let us find acceleration of B. How to calculate? Distance travelled, S is equals to ut plus of at square. How much distance it has to travel, ma? 1000 meters. What is the velocity of this one? Because both are in motion, we should consider velocity of B with respect to A. So, UBA, how much? 5. How much time we have? 40 seconds plus half into A we do not know. Again this is how much? 40 square. Now calculate. 1000 is equals to 200 plus 1600 by 2 into A. 2 ones are 2 800s. If you send 200 here, it becomes what? 800. 800 is equals to 800A. 800 by 800 is 1. So, A is equals to what? 1 meter per second square. This is whom? Acceleration of B. So, the B has to accelerate by 1 meter per second square, so that to avoid this accident. Okay, very important problem, don't neglect. Next, this is also a very good question. See what the question? Two towns A and B are connected by a regular bus service, with a bus leaving in either direction every 10 minutes. A man cycling with a speed of 20 km per hour in a direction A to B, in a direction A to B, notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in its opposite direction. Okay. Now, what is the time period of the bus service and what speed do the buses ply on the road? This is the question we should calculate now. Now, what is the question? Let us assume that A is Kolar, B is Mulbagal. We know that for every 15 minutes the bus will move from Kolar to Mulbagal or Mulbagal to Kolar. Here, according to the question, there are two towns A and B, they are connected by a regular bus service. A bus leaves in every T minutes. That T we have to calculate how much time. So, to find that one, they given one reference. What that reference? A man is cycling with a speed of 20 km per hour in the direction A to B, notices a bus goes by him for every 18 minutes and a bus coming forward in every 6 minutes. So, let us consider VB is equals to speed of bus, VC is equals to speed of cyclist. Now, for every 18 minutes bus move along his direction, right? Buses move along his direction. So, what we can write here? Distance covered we can write now. Distance covered by each bus. S is equals to velocity. Both are moving in. The cyclist and bus are moving in same direction. VB minus VC into what is the time taken? 18 minutes. So, we should convert into seconds. 18 by 60. Is it right? Now, what is the distance travel? Since a bus leaves for every T minutes, what we can write distance? Distance is equals to velocity of bus into T by 60. So, from these two equations we can write VB into T by 60, VB into T by 60 is equals to VB minus VC into 18 by 60. So, They said that for every 18 minutes the bus passes along with him. So, what is the distance travelled by bus? S is equals to distance velocity into time taken. Velocity we should consider relative velocity. Both are moving along same direction. So, VB minus VC, time taken is 18 minutes, so 18 by 60. Since a bus leaves for every 2 minutes, distance travelled is equals to velocity of bus into time taken. So, distance place we can write velocity of bus into time taken. So, equating these two we got VB into T by 60 is equals to VB minus VC into 18 by 60. Now, we can apply the same condition for opposite direction line. What that? For every 6 minutes a bus comes in opposite direction, right? So, for every 6 minutes a bus comes in opposite direction, distance travelled by bus in this case, right? S is equals to, now both are moving in which direction? Opposite direction, because the cyclist is coming in one direction, the bus is coming in opposite direction. For every 6 minutes 6 by 60. Same condition, what that? For every 2 minutes bus leaves, right? So, what is the distance travelled bus? S is equals to VB into T by 60. Combining these two, VB into T by 60 is equals to VB plus VC into 6 by 60. So, this is the condition for opposite and that is the condition for long direction. So, what you observe here? VB into T by 60 is equals to VB minus VC into 18 by 60, and here VB into T by 60 is equals to VB plus VC into 6 by 60. From 1 and 2 LHS are same, then we can equate RHS. What is RHS there? VB minus VC into 18 by 60 is equals to VB plus VC into 6 by 60. What are the things get cancel ma? 60 60 cancel, 6 1s are 6 3s are, multiply 3 VB minus 3 VC is equals to VB plus VC. 2 VB is equals to 4 VC, that implies VB is equals to 2 VC. First only they given, what is that? Velocity of cyclist, how much ma? 20 kilometer per hour. So, we can substitute the way, right? So, finally what you get? VB is equals to 2 into 20, nothing but 40 kilometer per hour. So, the velocity of bus that are plying on road is how much? 40 kilometer per hour. Next, if you substitute any equation from 1 or 2, 2 only can substitute. What is VB? 40 into T by 60 is equals to 40, VB is 40, VC is 60 into 6 by 60, 60, 60 cancel. What is the remaining? T is equals to 60 into 6 by 40. 22s are 23s are, 3 6 are 18, by 2 we get 9 minutes. So, for every 9 minutes there is a bus service from A to B. Okay, very important problem. Okay, the next and last question of this chapter, what is that is, a woman starts from her home at 9 am, walks with a speed of 5 km per hour on a straight road up to her office 2.5 kilometers away, stays at the office up to 5 pm and returns home by an auto with a speed of 25 km per hour. Plot the xt graph for her motion. So, she is a working woman. What she said that starts from home at what time? 9 o'clock. So, morning full energy, right? What she is doing? She is going to her office by walk. What is the distance of her office? 2.5 kilometers. Okay. So, she is traveling a distance of 2.5 kilometers by walk, and then she stays at the office and returns back to home, because after that she got tired, right? So she come back to home with a speed of 25 kilometers per hour, not in walk, by an auto, right? So we have to plot the graph for her motion. What is the distance now? 2.5 kilometers. Time taken to reach office. T1 is equals to distance by velocity. While going to office, she is going by walk, right? With what speed ma? 2.5 kilometers per hour, sorry, 5 kilometer per hour. Then time taken to reach office is how much? 2.5 kilometers by 5 kilometer per hour. Kilometers cancel, 2.5, so she will take 30 minutes or half an hour. Next, time taken to return home. T2 is equals to x by v2. With what velocity she is coming back? 25 kilometer per hour. Okay, what is the distance traveled? Same distance, 2.5 kilometers by 25 kilometer per hour. 2.5 ones are 2.5 tens are 1 by 10 hours means 60 by 10. So she will take 10 minutes to reach the home. Now her journey started here from what time? 9 o'clock and ended by above 5, right? Okay. So now we have to take the proper scales to plot the graph. So I am taking xt graph, time on x axis and distance on y axis. What is the distance? 2.5, right? Let us take it is divided into 0.5, 1, 1.5, 2, 2.5. The distance is measured in kilometers. Time we are measuring here what? In hours. Okay. She started her journey from 9 o'clock, right? Assume that 9, 10, 11, 12, 1, 2, 3, 4, 5. She started her journey where? At 9 o'clock and reaches to office by half an hour, means 9:30. At 9:30, so the value will be should be between what? 9 to 9:30 center, right? So she moved and started 9 o'clock and travels a distance of 2.5 kilometers. What time? 9:30 she is in office. So from 9 to 9:30 she is in motion, uniform motion. Then she stayed in her office up to what time? Up to 5 o'clock, no problem. She is at rest, not rest. She is working. Here no change in position, so we said that she is at rest. Okay. Then she reached home after 10 minutes, means by 5:10 she is at home, 5:10 p.m. So she started her journey at 9 o'clock and reaches the office by 9:30. She stayed in her office up to 5 and reached home by 5:10. So this is the way to represent the position time graph for any body motion. Understood, students? So this question is also important. If you understood the concept only, you can able to write what you have understood. So these are the problems that come for exam point of view, and you can solve a problem and you should answer me in the next class. Okay, I am going to give a small question for work. What that work is, this is homework problem. The given one velocity time graph. Speed is in meter per second, time is in seconds. The question is very simple, ma. Calculate the distance travelled by body in t is equals to 0 to 10 seconds. So, you know that this is velocity time graph. I am giving the clue that the area under the curve of velocity time graph gives distance or displacement. So, displacement is equals to what? Or we can calculate distance only. What happens here? Area under the curve of speed time graph. What is the area of this one? Rectangle. You know what is the area of rectangle? Substitute the values and get me the answers. Clear? You should answer and send me the photos, pics of the answered questions to me. Don't neglect. Right. Thank you.